question number 1 is asking us what the correlation coefficient of the linear fit of the data could be to about the nearest hundredth. You're looking at this graph. If I drew in a line of best fit, you can see it's a negative slope. So the correlation coefficient, the points look rather close together. I can probably get that a little bit closer. So if I were to draw this as straight as possible, the points are very close. So I would think that this is a negative correlation coefficient, close to -1, but it's definitely not a perfect correlation, because in order to be perfect, you would have to have every data point fall on the line. So choice 3 would be the best, would be the answer for number 1. Question 2, which correlation coefficient would indicate the strongest positive linear relationship between two variables? So the strongest would mean, again, R is always going to be a value between -1 and 1, so the strongest, or the one closest to +1 here, would be 0.79, choice 1. Question 3, which of the following residual plots would indicate that the linear model used to produce it was an inappropriate choice? So an inappropriate choice would come from a residual plot that forms a pattern. Choice 4 forms a pattern. It resembles some type of parabolic shape, whereas choices 1, 2, and 3 are all random. They would show a good fit for a linear model. Question 4 is asking us which of the following describes the correlation and association between the gas that remained and the hours that had passed. So again, if you kind of just tried to sketch some shape that would fit best at this data, we can see it's definitely not linear. So I'm going to get rid of choices 1 and 2. It does appear to have a negative correlation because it's going down. This looks like some type of exponential decay. So I would choose here choice 3. It's nonlinear and it's negative. For question 5, it says economists create a linear regression equation to predict the price of gasoline based on the price of a barrel of oil. They use the equation y equals 0.035x plus 0.95. So that's the line of best fit, the linear regression. One of the data points they use is 60, 3.62. So when they say data points, that means this is the actual point. So what I did was I went ahead and typed the linear regression equation into my y equals, and this is my table of values. I went to my table for 60, so I scrolled down, and the predicted y value is 3.05. So the actual y is 3.62, the predicted y is 3.05, and actual minus predicted gives us residual. So if you took 3.62 and subtracted away 3.05, you're going to get 0.57, choice 1. That would be the residual. For question 6, it gives us data that shows the temperature on a porch during several hours of the day. So you can see that they took data from 6 a.m. throughout the day until 9 o'clock at night. The temperature started at 45 degrees, it went up 50, 52, 68, 70, then it started to decrease again, 56, 49. So if we're talking about data that would be at a low point, then go to some high point and then start to come back down, that would not be exponential, would not be linear, but it could resemble some type of quadratic relationship. Question 7 gives us a graph that's illustrating the number of acres used for farming in small town New York over several years. So using a line of best fit, so I drew in a straight line here to show the best approximate line of best fit. It's asking how many acres will be used for farming in the 5th year. So if you look at about the 5th year here, that would be my predicted point. So based on this line of best fit, if I look over to my y-axis, it looks at about 2, and my y-axis is in hundreds, so 200, choice 2. Okay, so in question 8, we're given a frequency table with relative frequencies, and we're looking at, based on the table, which class shows the largest difference based on gender. So out of my math, English, and science classes, which one has the largest difference between girls who like math and boys who like math, or girls who like English, boys who like English, girls who like science, as opposed to boys who like science. What I did was I took the values in our chart, 0.33, and I took away the 0.39, so I found the differences. So in math, there's a difference of 0.06, about 6%. English, there's a difference of 9%. Science, there's a difference of 2%. So English has the largest difference, 9%. Choice 2 would be your answer. Number 9 says factored completely. What would this expression be equivalent to? So when I look at this trinomial, I can see there's a GCF of 2. So when I factor out that GCF, I end up with the trinomial x squared plus 5x minus 6. And the 2 is multiplying in front. So when I continue factoring, I have to remember that my 2 has to be brought down. And now I'm asking myself what multiplies to negative 6 while also adding to positive 5. And that's going to be positive 6 and negative 1. So this was choice 2. Question 10. What is 2 times the square root of 45 expressed in simplest radical form? So 45 is not a perfect square, but I want to think about factors of 45. So I'm thinking 1 times 45, I'm thinking 3 times 15, 5 times 9. So if I look at these numbers, I'm looking for the biggest perfect square that goes into 45. So I can see here that 9 would be the biggest perfect square factor of 45. So when I break open 45 into the 2 factors, I'm saying 9 times 5 is the same as 45. But because 9 is a perfect square, it's going to come out of the radical as a 3, since 3 times 3 is 9. Now, because there was a coefficient here of 2 in front of my radical, 2 times 3 is going to give me 6, and I'm left with 6 times the square root of 5, choice 3. Question 11. If a quadratic function has a turning point at 4, negative 5, and g of x, which is being based on f of x, is equal to f of x minus 3 plus 2, then where does g of x have a turning point? Okay, well I have to know what the minus 3 and the plus 2 are doing to my function f. The minus 3 is shifting g to the right 3 units, and that plus 2 is shifting g of x up 2 units. So if I take, again, let's just draw myself a little sketch here. If I take the original turning point, which we knew was 4, negative 5, this is my f of x turning point, and I go to the right 3 units, well 4 plus 3 would bring me over to 7, and if I go up 2 units, negative 5 plus 2 would bring me up to negative 3, so I end up over here for g of x at the point at the point 7, negative 3, which is choice 2. And the last multiple choice question here, number 12, gives us a linear function, d equals 0.25h plus 2.25, and this is modeling the depth of snowfall based on the number of hours since it started snowing, and they want us to interpret the equation. So the answer to this is choice 1, because what this equation is telling us is that the snow is falling at a rate of 0.25 inches per hour. The rate is our slope, and it started with a depth of 2.25 inches. So when we started calculating the snowfall, this was our y-intercept, otherwise known as the initial value. Okay, for question 13, we were asked to write a linear regression equation for the line of best fit for this data and round everything to the nearest hundredth. So first you had to start by typing in all of the heights in inches into your L1, typing in all the shoe sizes into your L2, and then going over to calculate under the stat menu, and choice 4 is for linear regression. So you'll notice over here, this is what I got in the calculator when I typed everything in. So if I'm rounding to the nearest hundredth, y is equal to ax plus b. So a to the nearest hundredth is 0.31, so that's what's multiplying x, and b to the nearest hundredth is 11.02, and that came out to be negative, so I wrote minus 11.02. So that's my linear regression equation. Then they want the correlation coefficient, so that is my r value, rounded to the nearest hundredth. So r is equal to 0.95 if we're rounding to the nearest hundredth. Then they ask us to determine whether the correlation coefficient indicates a strong linear relationship between height and shoe size, and to explain. So the correlation coefficient does represent and indicate a strong linear relationship. correlation coefficient does indicate a strong linear relationship and our answer, I mean, the reason we're explaining this, you could add if you want, because the value is very close to 1. Okay, for question 14, it gave us information about online video of a band, and notice it had been viewed 843 times after the first viewing. So they're saying a month later, the views had gone up to 1,708, and then if you look at the table, it shows us here that in month 2, this person forgot to record the total views, but then continued recording them the 3rd month, 4th, the 5th, all the way up to the 6th month. So we were asked to write a regression equation that would best model the data. So they didn't tell me write a linear regression, write an exponential. They just said to write one that would best model the data. So I really need to look at my data. I'm going from about 840 views all the way up to 1,700 views. Then we lose track. Then we have about 7,000, which is going up to about 14,000, which is going up to about 30,000, and then 62,000. So to me, it appears that these numbers are doubling. Not exactly doubling, but approximately doubling, which would be an exponential relationship. So what I did was I took my months, excluding the 2, so I left this part out for now, but I typed everything else from my months into my L1 and all of the total views into my L2, again, excluding the 2 because we don't have an L2 value for it just yet. So when you type this in and go to exponential regression, which is a little further down the list at choice 0, you are going to now round everything to the nearest hundredth. So the equation should have come out to be y equals 836.47 times 2.05 to the x power. And again, remember with these regression equations, it does tell you what the equation should look like at the very top. So you really, once you type everything in, just have to know how to round. Then it asks us to justify our choice of regression equation. So I would just state what I said before. I chose an exponential regression because the total views appeared to be doubling. Then it wants us to figure out what this missing total view number was for month 2. So they want us to use the equation from part A, so our rounded equation, and estimate the number of full views, so we're going to round to the nearest whole number, that he forgot to record. So we need to be plugging in here for x the number 2. When you type this into your calculator and you round to the nearest whole number, it comes out to be 3,515 views of that video in the 2nd month. Okay, for question 15, you were asked to first complete the 2A frequency table. So I'm looking at asthmatic students with a total of 182. 113 of them live in a home with a smoker. So if I subtract that from 182, that gives me 69 that would live in a home without smokers. There are 755 asthmatic, non-asthmatic students. Now I need to kind of look down because I'm missing with and without smokers in their homes. So if I look at the total of 395, which is my homes with smokers, since there's 113 students that have homes with smokers that are asthmatic, there should be 282 that are non-asthmatic that live in a home with a smoker. And if I add straight down here, 69, if I want to get up to 542, I would have to add 473 to complete the frequency table. Once you completed those values, you were asked 3 follow-up questions, and all of them were asked in percent, and then you had to round. So the first question said, what percent of students at this high school have asthma? So how many students are there? There are 937, and of those 937 students, how many have asthma? And that would be 182. Now, if you look over to the left, to the right, excuse me, I typed it into the calculator because I first need to make this into a percent. So if I take the percent, that would be 19.42369269264. And now I want this to be to the nearest tenth, so that would be 19.4%. What percent of homes without smokers have non-asthmatic students? So homes without smokers, that total would be homes without smokers, 542. And of those 542 homes, how many have non-asthmatic students? So 473. So when you take those numbers and you divide, you get the decimal on the right. But if I want to write it as a percent, it would be 87.26937269. And now I want to round that to the nearest hundredth. So now I'm rounding this one to 87.27%. And the last question, what percent of asthmatic students live in a home with at least one smoker? So there are 182 asthmatic students. And how many of those live in a home with at least one smoker? Well, we know that 113 of them live in homes with smokers. So 113 out of 182, again, gives you the decimal on the right. If we turn it into a percent, it would be 62.0879129. And we're rounding this answer to the nearest thousandth, so that would be 62.088%. Okay, and the last question here, number 16, gave us data, tutoring hours, the raw test score, and the residual. And the first thing we were asked for was to write the regression equation, and they tell us it's linear. They say y equals ax plus b for the raw test scores. So I took the hours and put them into my L1. I took the raw test scores, put them into my L2, and this is what I got in the calculator. So we're rounding here to the nearest hundredth, so my equation should be y equals 6.32x plus 22.43. Then we are asked to create a residual plot. Well, the nice thing is that they gave me all the residuals already, so I don't have to actually take my values and do actual minus predicted. That was done for me. And my residual graph was already given to me with intervals. So all I need to do now is take my total hours, comma, my residual, and plot that. So I'm plotting 1, 1.3. Again, approximate. 2, 1.9. 3, negative 6.4. 4, negative 0.7. 5, 2. 6, 6.6. And 7, negative 4.7. Okay, so that's my residual plot. And then it goes on to ask me, based on the residual plot, state whether the equation is a good fit for the data and justify. So I would say the equation is a good fit. Again, remember we're talking about a linear equation, so the linear equation is a good fit for the data. And the reason is because the residual plot is randomly dispersed above and below the x-axis.